works. So an individual's appearance and motion is the product of many complex and deeply interconnected elements. Like your brain controls your muscles, which drive the bones, which in turn move the tissues and the skin, and finally, the fabric of clothing on top. So in order to reproduce all of these and render a complete 3D avatar with data from only a limited number of sensors, we need to use a body model that replicates the human anatomy. This model needs to be fully adaptive to perfectly match any individual automatically, and it needs to be physically based to replicate actual, genuine behaviors. So how do we do it? Now, to build that model, we start from the inside out. So first, we study medical literatures and used advanced medical imaging references to design an anatomically correct human skeleton with the proper articulations and degrees of freedom. So that model is far more complex than those used in traditional animation. Think of how your shoulder blade slides, like your hips roll or your joints stretch even a little bit, just to enable you to do the subtle gestures that are unique to you. Next, we match the skeleton to the user's body structure and animate it in real time. And as the user moves around, the model continues to adapt to this unique individual and is more faithfully able to reproduce that person's movement. So as you can see in this video, the skeleton is matched with Tony, one of our researchers, who is observed by a single sensor. And notice how subtle motions like the shoulder roll here are accurately captured. We can't stop at the skeletal level, though, where it looks a little creepy. And what really drives the motion of the skeleton are the muscles. Now, the muscle movement is critical to understanding behavior and intention. So this sequence here shows real-time tracking of Tony's muscle activation. Now, to do this, we use the inertia of his body and the musculoskeletal system to help us predict and stabilize his motion. Modeling the deformations that occur when the muscles contract is also critical to creating a realistic reconstruction of the body. Now, of course, skin, hair, and clothing are the most visible layers. And for clothes and hair to interact realistically with the body, we need to reconstruct and simulate them as faithfully as possible. So here we use visual observations to infer the body geometry and reconstruct its shape. And then we apply physics-based model to reproduce actual cloth deformations. And we need to be able to accurately match people's actual garments, even under challenging circumstances, like this here. All right, so now let me show you what this looks like in an early prototype of a simple live interaction. So here you'll see two people, Alex and Tony, who could be remote in different locations, animating their avatars in a shared virtual environment, that soccer field on top. So keep in mind that doing this without any suit or marker, in real time, with minimal hardware for capture, is groundbreaking. So let's take a look. And watch her reaction here, how she jumps. Like she's totally immersed in the experience. This is very cool. Now, as you can imagine from that example, latency will be critical. It's one of the big challenges we need to overcome before this turns into a shippable product. We also need a way for people to easily generate and animate their avatars using off-the-shelf sensors. Now, before we ship this, we also need to make sure we answer some key questions around privacy and security. One of the questions is making sure avatars are authentic. And there are a number of ways we can do that. For example, we can make sure your avatar is tied to your account and your identity. To prevent others from accessing your avatars, security and identity verification options will also be key. So fingerprint and facial recognitions are already used in mobile devices around the world, so building them into future devices may ensure only you can access your avatar via your device. Another critically important